Hi, welcome to another lecture on precalculus. Today's topic is converting rectangular coordinates to polar coordinates. We want decimal answers. Facing any of these questions, always good to go through a set of formulas that are relating these two coordinate systems to each other and start from there. So remember that when we have a Cartesian coordinate system, a point has coordinates x and y, and of course this is the y of it and this is the x of it. The polar coordinates are this hypotenuse, which is now called the radius r, and this angle theta. So you remember r squared is x squared plus y squared. That's just a Pythagorean formula, and tangent of theta is y over x. So these are the relationship that connects these two coordinate systems to each other. So I have a point with coordinate 3 and minus 1. So 3 and minus 1, 1, 2, 3, and minus 1, so I'm here. Well, finding r is going to be easy. This is 3, this is minus 1, so r squared is 3 squared. I put them in parentheses so there would not be any mistaking with the signs. So 9 and 1 will be 10. That's r squared, and the positive root is typically required, so radical 10, and then radical 10 we go ahead use our calculator, and the problem shows a calculator to you on the screen, and we just use that. And so here I have my trusty calculator here, 31622. It says to nearest hundredth, so we have to round to here, and if this number is 4 or less, we just skip it, and if it's 5 or more, we just go up. So r is going to be approximately 3.16. With respect to theta, we have several choices. We could go theta this way, or we can come and find the theta that way. So either of these two is going to work. You want to write theta is arc tangent of y over x. If we are on the first or fourth coordinate, this is going to do. If we are on the second or third quadrants, then we have to make a small adjustment. So here arctangent of y over x, I'll have or we can write it as arctangent of, my y is minus 1, my x is 3, minus 1/3. I know that angle is going to be negative, so arctangent of, make sure you practice this thing on your calculator. It's asking for degrees, so you want to make sure that that is right, and that if you are entering negative numbers in your arctangents, make sure your calculator can actually understand that. So this is going to be minus 18.4349, etc. And again, to two decimal places, we are going to have minus 18.43. So we just wrote down the easier one, which is this negative angle here. If you want this positive angle, just add 360 to this and you get another answer. So 3.16 and minus 18.43. Pay attention that it's degrees. You have to set your calculator into degrees. And make sure your arctangent works correctly. Now the issue is, as I mentioned, when you are using calculator, you have to be careful. Let me just make, oh sorry, that was strange. So if I had the point with coordinates say -2 and 3, okay, so if I'm here, that is the angle we are looking for is this one. If you so let's write again. So we have x squared plus y squared, that's equal to r squared, and tangent of theta is also y over x. So with respect to r squared, we never have any problem. So it's -2 squared plus 3 squared, and that's going to be 4 and 9 is 13. So r is going to be square root of 13, and just as before, we're going to find that. So square root of 13, let me just type it while we are here, and we have square root of 13, so 3.6055. So this is when I want to round it to 2 decimal places, 61. More difficult issue is how about the angle. So the angle is, so we know the tangent of theta is going to be, the y is 3, so this point with coordinate -2, 3. It's 3 over -2. Now what's the difficulty here? Difficulty is the calculator only sees the most standard calculator. They just see the ratio, that it is -1.5. Well, it could have been -3 over 2, or it could have been 3 over -2. The calculator doesn't know which one of these you meant. It just takes it to be -1/2. It essentially resolves the issue like this. They are all tangent inverses. They always assume that you are looking for the angle here, that is what you wanted, which of course that's not what you wanted. You want to be in the second quadrant, and this is in the fourth quadrant. So what is the remedy there? The remedy is that well, you add a pi to this. So our theta, when this is the number we are after, is going to be pi plus tangent inverse of -1.5. Okay, so you have to always make sure you're in the right quadrant. You can do this thing several ways. Let the calculator bring you here and add the pi to it. So it forces you to come here. So okay, I come with you. I come down here, and then I add pi to it to rotate by 180 degrees to take me to the second quadrant. And I wrote pi. I have to correct myself. Let me see. Of course, we are all dealing with degrees here. So 180 plus tangent inverse of. Another option that you have is to use reference angle. That always strip the negative signs away. Find out what your angle is, and then from the information of which quadrant you're in, figure out your answer. So how would I do that? I say, okay, this angle, this reference angle, it will be tangent inverse of 1.5. Okay, positive number. Now what? To be in the second quadrant, I'm going to start counting this location at 180 degrees and back up by that amount. So it's going to be 180 minus tangent inverse of 1.5. These two will be the same thing. So okay, now let's go ahead and figure that out. So 180 minus arctangent of 1.5, so I get 123.69 degrees. I prefer this style, less error prone, less problem with the calculator. You force yourself to come and see which quadrant you're in and then figure it out like that. Let's go ahead and practice one more example. I just make some numbers up here. So suppose we have a point with the coordinate -2, -3. So where is that? -2 and -3. So it's obviously in quadrant 3. What angle you want? Well, you have a choice of going clockwise or counterclockwise. Let's just go counterclockwise here. R squared, again, -2 squared plus -3 squared. So that is going to be 13. So R is again square root of 13, no problem there. How do we handle the angle? Say, okay, our reference angle is this. Let's call that theta prime. Theta prime, we just know that opposite is 3, adjacent is 2. So that is tangent inverse of 3/2. Okay, so this is 3, this is 2. So we are just looking at that triangle. In reference angles, we don't bother with signs, with negatives or anything. Just deal with pure numbers. So that is 3, that's 2. The angle is tangent inverse of 3/2. So whatever that is, let's just type that in. We have tangent inverse of 3/2. So 56.3099, excuse me, 56.3099, so that is 56.31. I want this angle, theta. What's theta? Is 180 plus theta prime, so it's going to be 180 plus this. Okay, so in quadrant 2, if you want to use this, it's good for quadrant of everything. Of course, it's good in quadrant 1, no issues there. 1 and 2 is good. If you are in excuse me, again I made a mistake here, sorry. Quadrant 1 and 4, so if you are here or you are here, that's fine. If you are in quadrant 2 or 3, you want to use your calculator, well, go ahead and use it and add pi to it so that you are in correct quadrant. Alternative to this was to use reference angle. So your reference angle, you find your reference angle first and then adjust to it accordingly. So if you want to use reference angle. Well, if you are in quadrant 1, theta is just your alpha. If you are in quadrant 2, so if you are here and this is your alpha, then your theta is pi minus alpha. If you are so quadrant 1, quadrant 2, quadrant 3, so in quadrant 3, if you find your angle alpha in quadrant 3, then your theta, so theta goes from here to here, here goes from here to here. This is pi plus alpha. If you are in quadrant 4, if you are here and you have figured out this reference angle alpha, theta, you have an option of saying minus alpha, that's going this direction, or if you wish to go this direction, you have that option as well. So that's 2 pi minus alpha. Either of them will work. So that takes care of all possibilities. We learn to go between these two coordinate systems. Actually, we learn to go from rectangular to polar. Okay, until the next mini lecture, good luck and God bless.